Hello everyone. In this video, we're going to be solving a geometry puzzle. If you like this video, please comment, like, and subscribe, and hit the bell button for notifications, and let's get started. First of all, I just want to say that this puzzle was inspired by Edwin Wallace, one of my colleagues on Twitter. I'm going to share the link to his Twitter account and the tweet in the description down below, and let's go ahead and get started. Now we do have a square that's inscribed in the region between a quarter circle with radius 1 and a 30, 60, 90 triangle. Find the area of the square. Okay, now I just want to tell you something about this puzzle that, trying to set it up, drawing this one wasn't like super easy. You had to figure out where those points are, the coordinates of the square, so on and so forth. It took a little bit of coordinate geometry, but in the solution, we're not going to use those ideas. But definitely, if you want to look into this, I can also share the link to the Desmos drawing on Twitter if you let me know. It was kind of interesting. Anyways, so what are we supposed to do? We're supposed to find the area of the square, right? To find the area of the square, I do need the side length. So, and notice that the square is kind of pretty close to the bottom, right? So where is that square? That square needs to be situated in such an, exact location that both of the vertices are on the circle. Does that make sense? I mean, you can draw many squares in this region, but it won't be like all the four vertices won't be like this. Okay, so this is unique. Anyways, so let's go ahead and start here at the center of the quarter circle. And this quarter circle has a radius of 1, so it's kind of like a unit quarter circle or quarter unit circle, whatever you want to call that. So what I'd like to do is I'd like to connect the center of the quarter circle to one of the vertices of the square. But I want to make it in such a way that I make a perpendicular segment. Okay, so I'm going to go like this. I'm going to start here, and I should hit the square, something like that, and stop here. Okay, didn't go as expected. Let's try again. All right, so let's see. So something like this. Okay, cool. I think that's good. Now, what is so critical about this segment is that, first of all, it doesn't go all the way in. I mean, it doesn't need to, because I want to be able to use the side length of the square. So let's call that x. Okay, so this will be x. And also notice that it's going to hit the square here at a 90-degree angle, right? Okay, so that's important because we have a 30, 60, 90 triangle, and we want to be able to use that in our solution, right? Okay, so we got a right triangle there, which is good. And what else? Okay, is it hitting at a random point? Nope. If you actually complete the square, you'll notice some type of symmetry here. What is that symmetry? Well, that square needs to be placed right in the middle. If you draw the chord, if you extend it, if you extend the quarter circle, and then from symmetry, basically, so to keep a long story short, what I'm trying to say is that this is going to hit right in the middle. So this is going to be half of x, and this is going to be half of x. That's what's really critical about the solution of this problem, that it hits in the middle. Okay, cool. Now, we're going to make another connection here. So I'm going to take one of the vertices and connect it to the center like this. And that's actually going to be another critical connection, because this also gives us a right triangle like this one. Okay, cool. Now, we do know some of these lengths because, first of all, we know that the quarter circle has a radius of 1. Okay, good. So the height in this case, I would say, the height of this triangle would be 1, right? Okay, good. So, and this is a 30, 60, 90 triangle. So this is 30 degrees and this is 60 degrees. Great. So what do you know about 30, 60, 90 triangles? The longer leg is square root of 3 times the shorter leg. So if the shorter leg is a, in this case, then I can safely say that a times square root of 3 is equal to 1, which means that a is equal to 1 over square root of 3, which you can write as square root of 3 over 3. So again, that's a critical segment because we want to be able to use the Pythagorean theorem, obviously. And one of the right triangles we're going to use is this one. Let me shade it for you. Here we go. And the other one is this one. So that's basically the plan. We're going to be using that right triangle and the Pythagorean theorem to find length x, and then we're going to find the area of the square. Okay, cool. Now, how do we go from this to the length of the square? Well, first of all, we do have to find another length here. What is that length? Well, that length is b. Let's call that b, okay? So between these 2 points, we have a little segment there. What do you know about that? Well, this is 30 degrees because this is 60 degrees, right? Okay, and this is a 90-degree angle. Cool, that's a 30, 60, 90 angle. So what do you know about the relationships? The hypotenuse is twice the shorter leg. Okay, good. So what is the shorter leg? The shorter leg is x over 2, right? Well, actually, no, that's not x over 2, because notice that this is the shorter leg, but it's actually longer than x over 2. So we have a little piece here. We don't know what it is, and we don't really care. What really matters is that, can I find the relationship between a and b directly? Forget about x over 2 or that length. Okay, how do you associate the hypotenuse with the longer leg? Okay, here's how we can do it. Well, if you cut the hypotenuse in half, right? Cut the hypotenuse in half, you get the shorter leg. So it's half of a. So this is actually a over 2, in other words. We don't know what a is yet, but we'll find out. So half of a, and then that's the shorter leg, and I want to find the longer leg, b. So b is going to be square root of 3 times the shorter leg, right? Okay, that's it. But what is half of the shorter leg? Well, half of the shorter leg is just going to be half of square root of 3 over 3 from here, and that's going to be square root of 3 over 6. When you multiply root 3 times root 3 is 3 over 6, and this is 1/2. So b is equal to 1/2. Nice. Okay, what's that supposed to mean? It means that b is equal to 1/2. Significant, right? Okay, cool. So b is 1/2, and this is also x. Notice that? And this is half of x. Beautiful, right? Okay, so now in this right triangle, which I'm going to shade again, I can use the Pythagorean theorem. How? Well, the base is 1/2. You see that? 1/2 plus x. And then the height is x over 2. And the hypotenuse is the radius of the quarter circle, which is 1. Okay, so here we go. We have 1/2 plus x squared, right? Plus, okay, half of x. Remember, the height is half of x. Half of x squared. And the radius squared is 1. Great. So we do have a quadratic equation. We can solve this, right? Okay, well, we've solved some quartic equations, some quintics, some, heptics, so on and so forth. Was it heptic or septic? I think it was septic. Anyways, so what do we do with this? We're going to square this, so it's going to give us 1/4 plus 2ab is going to give us x plus x squared plus x squared divided by 4 is equal to 1. Now at this point, you can just go ahead and multiply everything by 4. I just like doing that because it really eliminates all the fractions and it kind of makes it a little easier to solve. Multiply everything but everything by 4. Okay? Then we get 4x squared plus x squared, which is equal to 5x squared plus 4x. Then 1 minus 4 is equal to, because we're going to have to bring this 4 to the left by way of subtraction, and that's going to be a -3. Okay, so that's our quadratic. How do you solve this quadratic? Well, unfortunately, this is not factorable because the solutions are not rational. Okay, so we can always use the quadratic formula. You can also complete the square here, but you know what? It's a little painful. You got to divide both sides by 5, and then you're going to have to deal with half of 4/5, so on and so forth. It's kind of painful, but you can do it if you want. I'll use the quadratic formula. So x equals -b. Oh, another thing that I'd like you to notice about this problem before we get into the what's it called? The two solutions case, because a quadratic equation normally has two solutions, right? Sometimes the solutions are repeated, but it should have two solutions. Sometimes real, sometimes not real. They can be complex as well. In this case, we should have real solutions because, I mean, come on, we're looking for the length of something, right? It should be real. So, but how do you distinguish between the roots? Well, from Vieta's formulas, remember we had a video on Vieta's formulas back then. We had some problems on Vieta. So Vieta is cool. And Vieta told us that the product of the roots here, which is x1 times x2, is -3/5, which is less than 0. So when the product of two roots is negative, which this means that one of the solutions is positive, the other one is negative. Are we interested in the negative length? No, not really. So we're going to go with the positive length. Okay, cool. I just wanted to make that clear. And vieta is always important. So I encourage you to use it. Negative b plus minus, but just plus, square root of b squared, 16 minus 4ac. Now, when you multiply, c is negative, so that's going to turn it into a plus sign. 4 times 5 times 3 is 60. Okay, is that right? Yeah. My arithmetic sometimes fails me, so yeah, I hope I got it right. I think I did. Okay, cool. So now this is what we get. And then 16 plus 60 is equal to what? 76. So I'm going to write that first because it kind of looks cooler that way. Divided by 10. Now, obviously, this can be simplified. Why? Because 76 is divisible by 4, which is a perfect square. So I can just go ahead and take it out. So 4 times 19, that should give me x is equal to 2 times the square root of 19 minus 4 divided by 10. And as you can see here, everything is divisible by 2. If we divide, we should be getting the following answer. And this brings us to the end of this video. Well, thank you for watching. I hope you enjoyed the video. Please let me know in the comment section down below. Like, comment, and subscribe. And I'll see you tomorrow with another video. And this video is going to be on floor values. All right. See you there. Bye-bye.